Hello everyone, welcome back to my channel. So today again we are going to solve an issue related to production planning. So first of all, we'll go through the problem statement, we'll analyze those statements, and then we are going to solve the issue by using the Excel solver. This time we have made the problems a little bit complex by adding an extra constraint like demand. So considering the demands in the mind, we have to create a model, and ultimately we are going to find a solution by using the solver. So let me share my screen. All right, I hope that you are able to see my Excel file. Okay, so let me read it out the problem statements. The demands for 2 weeks for a product are 800 and 1000 pieces. So let's assume that we have only one product and the demands for week 1 is 800 pieces and demand for week 2 is 1000 pieces. So let me write it down. Let's consider we are speaking for 2 weeks as of now, week 1 and week 2. Okay. And we have only one product 1. Okay. And what is the demand? The demand for week 1 is 800 and for week 2 is 1000. So this is our demand. Okay. In a week, the company can produce up to 700 units in regular time at 100 rupees per product. So basically, if we consider regular production, we can produce 700 pieces maximum, max production. Okay. And what is the cost? What is the cost? The cost is 100 rupees per piece. That is a regular production cost. Okay. Now, it can employ overtime and produce up to an extra 300 units in a week at 120 rupees per product. So in case we need to do a overtime production, as per the problem statement, we can produce up to 300 units in a week. So that is the maximum units that we can produce during overtime production. Okay, so we can write it down. This is the maximum production capacity in case of overtime. Okay, per week. And what is the cost? If we produce 300 pieces in a week during the overtime, then the cost of production increased from 100 rupees to 120 rupees per product. That means again we can say overtime production cost per piece is 120 rupees. Correct? Now, the cost of carrying a product from 1 week to the next is 25 rupees per product per week. So there is one another angle, carrying cost. Or you can also consider this as an inventory holding cost. Okay. So inventory holding cost is per piece per week. As per problem statement, it is 25 rupees. Correct? That is what they have mentioned. Now, what we need to find it out? How should the company produce to meet the demand at the minimum cost? That means we need to fulfill this demand as per the week-wise basis. And also we need to find out what will be the minimum cost to fulfill this demands on weekly basis. So this will be our objective. Okay. So basically we can write it like this way: week 1 and week 2. Okay. So demand for week 1 is 800 and for week 2 it is 1000 pieces. Okay. Now regular production and overtime production. So these two things we need to find it out. These two things we need to find out by using the Excel solver. So this becomes our decision variables. Okay. And carrying pieces. Okay. So carrying pieces will be regular production plus overtime production. Regular production plus overtime production minus our demand for week 1. So that will be our carrying pieces. Okay, per week. So carrying pieces for the second week will also remain more or less the same. So for the week 2, we can mention regular production plus overtime production plus the carrying pieces of week 1. That means, for an example, for week 1, if we produce 1000 pieces and we have a demand of 800 pieces, then that extra 200 pieces we need to consider for the week 2. Okay, so basically the thing is like the thinking is like we do not want to overproduce anything for the week 2, right? So that is why we are also considering the extra pieces of the week 1 in this carrying pieces also. Okay, and minus the demand of the week 2. So that remains the same. The logic remains the same. Okay, now if we consider the total cost, so we have 3 different types of costs, right? Now consider the regular cost. Now what is the regular cost? The quantities which we are going to produce for week 1 and week 2 should be multiplied with the regular cost production, that is 100 rupees. So that becomes our regular cost. Okay. There is one another cost, overtime cost. So again, the logic remains the same. The quantities which we are going to produce for week 1 and week 2, that means these sales, multiply with the overtime production cost per piece, which is 120 rupees. Okay. Now there is one another one, carrying cost or the inventory holding cost. So that again remains the same. This cell plus this cell multiply with how much? Carrying cost per piece per week, that is 25 rupees. Okay, so we can mention total cost will be summation of all these 3 costs, that is the regular cost, the overtime cost, and the carrying cost. So this becomes our OFB. So what is again our OFB? Our OFB is to minimize the production cost. Okay. Now what are the constraints? So here we have a lot of constraints. So let's see what are those constraints. So first of all, let's consider the demand. So we need to meet the demand. So that is written in the problem statement, right? So for week 1, the demand is 800 pieces. For week 2, the demand is 1000 pieces. So that we can write it here. The quantity of regular production plus the quantity of overtime production should satisfy the demand of week one, that is 800, right? So we can mention as summation of regular production plus overtime production of week one should be greater than equals to 800. It needs to satisfy the week one demand. Okay. Similarly, for week two, we can mention regular production plus overtime production plus the inventory of week one, the leftover inventory of week one should be equals to how much? The demand of week two, that is 1000 pieces. Okay, so here we are not mentioning greater than equals to 1000. Why? Because we do not know that whether we need to produce anything for week 3 or week 4 or not. So that is not very much clear in the problem statements. So that is why we are only considering that we need to focus our production planning based on this problem statement. And as per this problem statement, we have only 2 weeks, week 1 and week 2. So that is why I have mentioned here equal to. Otherwise, if there are problem statement that we need to do the production planning for week 3 or week 4 or something like that, then definitely we can mention here greater than equal to 1000. So logic needs to be clear that we need to satisfy the demand at any cost. Okay, so as of now, we have 2 weeks of demand. So first of all, in the first case, we have mentioned greater than equals to demand of week 1, because whatever the leftover quantity for week 1, we can consider those inventory in the week 2. Okay, so that is why we have mentioned here greater than equal to 800. But in the second case, we do not have any type of problems for the week 3 and week 4. So we are considering it the week 2 as a final weeks where we need to do the production planning. So that is why we have mentioned here equal to 1000. 1000 is what? The demand of week 2. Okay, so demand constant I have already added. Now look, see what are the other constant we have. So regular production. So maximum regular production is 700 pieces. Okay. So here we can mention this one. That is the regular production of week 1 needs to be equal to 700. Why I have mentioned here equal to? Because we need to focus that our regular production needs to be at 100% capacity all the times. And if we follow this logic, we can at least save, as per this problem statement, 20 rupees per piece. How? If you see, the cost of regular production per piece is 100 rupees and the cost of overtime production per piece is 120 rupees. So if we use our regular production capacity at 100%, at least we can save 20 rupees per piece. Okay, so that is why I have mentioned here 0 equal to 700. So the logic is we can able to use our regular production capacity at 100%. Okay, so similarly for the week 2 also we can mention regular production of week 2 should be equals to 700. Okay, now let's come to the overtime production. The maximum overtime production per week is 300 pieces. So we can mention here overtime production of week 1 should be less than equals to how much? 300. Above 300 we cannot produce. Okay, and again for the week 2 we can mention overtime production of week 2 should be less than equals to how much? 300. Okay, so I guess we have added all the constraint now. Yeah, so we have added all the constraint now. We have formulated the model. Now let's find the optimal solution by using the Excel solver. Now go to the data, go to solver, reset. Okay, so what is our objective function? We have already formulated our objective function here. So click that cell. Here we need to find out the minimum cost, right? So instead of max, here we need to select the mean quantity, the mean thing. Okay, so select this mean. Now, what are the variables? Yes, we need to find out what will be our optimal production planning by considering all these constraints. So we need to select these cells, regular production and the overtime production. Okay, now what are the constraints? So this one is a constraint, should be greater than equal to how much? 800. Okay, click on add. Now, so see, I am adding all these constraints at the same time because they have the same symbol, that is equal to. Okay, so here we can select the equal to, and these are the values. Okay, click on add. Now again add this constraint, should be less than equals to how much? 300. Okay, so I have added all these constraints. I can make unconstrained variables non-negative tick because we need to find out the production plan of week 1 and week 2, and we do not want any type of negative values here. So if we do not want any type of negative production values, then always tick this option. Okay, now we are going to use this algorithm, simplex LP, because this is a linear program. Now click on solve. Okay, now as per this production plan, this is the production plan. Okay, so as per the Excel solver, for the first week, we need to do a regular production of 700 pieces, and we need to produce a overtime production of 100 pieces. Okay, so if we do a summation of these, we are fulfilling the demand of week 1, that is 800 pieces. Okay, for week 2 also, as per Excel solver, we have to produce 700 pieces of regular production and 300 pieces of overtime production. So if we do the production like this way, you can able to fulfill the demand of the week 2. Okay, and what is the minimum cost that we are generating? This is the minimum cost that we are generating if we follow this production plan by considering all these constraints. Okay, so this is the minimum production cost, and this is the production plan based on these constraints. Okay, now if you want to see that whether the Excel solver fulfill all the constraints requirements or not, you can see from here only 800 less than equal to 800. So it is fulfilling the first constraint. This one also get fulfilled by the Excel solver. They fulfill these two also. Okay, and this one also got fulfilled. This one also got fulfilled. So Excel solver considered all the constraints that we have applied, and based on that, this is the base production plan where we can generate the minimum production cost. All right. So I hope that you liked my video, and in this problem, we have added some different angles to make this more complex. For an example, we have added here the regular production, the overtime production, and the inventory holding cost, so that it becomes more complex and you can have a generic idea that if you get this type of problems, then how to build a model and ultimately to find a optimal solution by using the Excel solver. So yeah, keep watching, and thanks for subscribing. And if you have not subscribed, please do. Thank you.